Hello everyone, I am Ümit Alkuş. In this video, we will solve one problem in Chapter 8. The spring in the figure can be compressed by 5 centimeters by the application of a 40 Newton force. Before proceeding, let us calculate the spring constant K. We have the magnitude of the restoring force equal to K times X. From this, we obtain an expression for K as F over X. Now, put the given numerical values into this equation. 40 newtons over 0.05 meters. Therefore, we obtain the spring constant K as 800 newtons per meter. Okay, let us continue to the problem. The coefficient of kinetic friction between the block and the inclined plane is mu k as 0.15. The mass of the block m is 2 kg and the inclination angle theta is 28 degrees. Starting from rest, the block first slides down a distance d, then compresses the spring by 12 centimeters and momentarily stops. Calculate the distance d. In order to solve the problem, let us draw the free body diagram of mass m. The proper coordinate axis is as follows. We represent the block by a big dot. After that, we draw all the forces acting on the body. The gravitational force is a downward force of magnitude m times g. Now it is convenient to decompose this force on the x and y axis. Because there is a contact between the block and the inclined surface, we have the normal force perpendicular to the surface as follows. Finally, because the block goes down along the surface, then the kinetic frictional force becomes an upward force along the surface. As the final step to draw the free body diagram, we draw the acceleration vector for the block as the following. Now we write the equation of motion by the help of the Newton's second law F net equals ma. Since there is no motion along the y-axis, we have n minus m times g times cosine theta equal to 0 because acceleration along the y-axis is 0. From this, we obtain an expression for the normal force as n equals m times g times cosine theta. Next, the magnitude of the kinetic frictional force denoted by Fk has the expression mu k times n. Put the value of n to obtain Fk as mu k times m times g times cosine theta. Okay, that's all about the free body diagram and the equation of motion of the block. According to the figure, we have the right triangle like this, where x is the amount of the compression of the spring. Finally, we can write h equals d plus x times sine theta. The conservation of total energy can be written as the initial total energy equals the final total energy. We have initially the gravitational potential energy and the kinetic energy of the block. The final total energy is composed of the final gravitational potential energy, kinetic energy, the potential energy stored in the spring, finally the thermal energy due to friction between the block and the surface. Its value is equal to the absolute value of the work done by the kinetic frictional force, namely the absolute value of the dot product Fk dot d plus x, where d plus x is the total distance during the motion for the block m. Then the thermal energy becomes the absolute value of Fk times d plus x times cosine 180 degrees. Cosine 180 degrees is negative 1 and the absolute value of negative 1 is positive 1, therefore the thermal energy due to friction becomes Fk times d plus x. Anyway, this is the conservation of total energy. According to the right triangle in the figure, if we take the bottom level as the zero gravitational potential energy level, the initial gravitational potential energy of the block becomes m times g times h, because it is height h above the zero gravitational energy level. The initial kinetic energy of the block is 0, because the initial speed of the block is 0. The final gravitational potential energy of the block is 0, since it is at the bottom. The final kinetic energy of the block is 0, since it momentarily stops at this point. The potential energy stored in the spring is 1/2 k times x squared, because it is compressed by length x. Since the thermal energy is Fk times d plus x, and Fk is mu k times m times g times cosine theta, we have the thermal energy as mu k times m times g times cosine theta times d plus x. So, if we rearrange the formula, we obtain, from the right triangle in the figure, h equals d plus x times sine theta. On the left hand side, m times g times d plus x is common. From this, if we divide both sides by m times g times sine theta minus mu k times cosine theta, we obtain d plus x as, or if we take x on the left hand side to the right hand side, we obtain an expression for d as, if we insert the numerical values into this equation, we calculate distance d as 0.752 meters. Or equivalently, distance d is approximately 75.2 centimeters. This result brings us to the end of the discussion of this problem. Thank you for your attention. See you in the next video.